All right, I'm back. Okay, now let's move on. This example will be more complicated than the last one. Right? We are going to simulate the change in the stock market price for this one, and the next one we are going to simulate the success or the failure of the portfolio. Right? What is portfolio? In terms of stock market, the portfolio refer to the number of stock that one holds, but you can invest in multiple of them in order to balance the risk. This doesn't apply only to stock market, right? It can apply to project picking. It can apply to a lot of risk management. So we are going to just use this as example and then see what happened here. Okay, so we are going to simulate it, right? This is not the new example. It has been investigated by a lot of prior researchers or prior modelers to this. The aims of this study is to investigate the different investment strategies and to find the best strategy that would give you the positive result over a long period of time. Okay, and so investor can define the decision method that they use. So the goal is to perform simulation. We need to perform simulation of the asset, the stocks. I mean, the what you want to invest, and say having some goal like each day we'll update the allocation between the cash and the stock, and then increase the total value of asset over time. So if the stock go down, maybe you want to make investment. If it go up, maybe you want to sell, or the other way around, depending on the strategy. For example, this can be an investment, although it might not. Usual advice is like buy low, sell high, right? But this is just a simple example. If the stock is high today, then you, if it's going to go higher, maybe you want to spend to purchase. If it will decline, and you might want to sell. Or you can have the reverse strategy of this, whatever. You can have waiting till things happen. You can have thresholding. If it goes up to a certain point, sell or buy, whatever. And you can include something like the commission, the amount of money you need to pay for the provider, the broker. Usually, there will be broker like a lot of companies that you need to create an account so that you can purchase stock of the Thai stock market. All right. So for our modeling, we need to postulate certain assumptions in order to create a model. Right. So first assumption would be something like this: that the stock price of today is affected by the previous day. So what happened yesterday would have effect today. That's usual, right? But there is a change which is random. Right? This randomness comes from people wanting to buy and want to sell that. And after capturing the variations, if we calculate that and find that they're comparing, if we compute the variation like the sigma of the change in the price, we find that sigma is like 1% of the price in the previous day, and mean is 10% of the price in the previous day. For example, it can be like this. And suppose that the previous day stock price went from 100 and 210. That means today's change would be sampled from the normal distribution to something like the mean of 1 and the standard deviation of 1% of 100, also 1. That means we capture the variation of yesterday's change and then use it to simulate the next day change, like this one. P price of n plus 1 will equal the price of n plus this change. And this change occur from sampling from the normal distribution of the change of the previous day. So if the previous day increased, so there's a chance of it to change with the mean of that increase, but there is a variation of the previous day as well that we use to do this. That means n can be plus or minus. If n is minus, means it's go down. If n is plus, means it's go up. So by making this assumption, we can transform the assumptions into mathematical construct here, and then we can perform simulation, simulate it out. How to do that? You need to just sampling this. So for the start, we start with stock price of 100, and we hold a share of 500, have cash of 50,000, total worth once multiply in, you get total worth of 100,000. And if we put in policy that price go down, sell, right? Price go up, buy. Then we have this. So it doesn't mean that this is correct, okay? Just to show you that you can incorporate the policy into this one, right? If price go down, you sold 10% of the share. Price go down here, so 10% still hold. So the price go down, you have this, total worth reduced. At the end of the day, you decide to sell 10%. And then the other day, you have the stock equal this one of 54. And then the price change, right? So how the price change? The price change independent of the thing that we have here. So that means this column doesn't depend on the other columns. These columns come from the simulation, right? It comes from the simulation. That is using the equation that we have here. We just need to sampling from normal distribution and then add to the values. Then you get the change. But you cannot do it. You need to have the values of the change in previous day first to do that, because you need the change in previous day to become the mean of today. That means you need to kind of iterate through that. I did not have example here. You can implement it. It's not hard actually. Just need to you can actually you can use R and then using for loop in that, and then doing this by yourself. And then you can then evaluate the whether this strategy give you a better total worth or not, if the change is like this one. Okay, putting the stock price like this into graph, you get a graph that looks like this one. You can see that it's quite, if you take a look at the real thing, it's quite it's like the actual things. This is actually, it does have the name, this type of technique, right? It's called random walk or Markov chain. All right. So my suggestion, you can try this. This is a simple form of Markov chain and random walk. For just one stock price, you can simulate it out. And it has the root that link to actually the famous like Einstein and Brownian motions that is studied in science as well, using this one. Right. If we increase, if we increase the number of you can plot the simulated stock price. You can plot the change in the total worth, the change in the share, the amount of share, and the amount of cash you hold, and this allow you to estimate the policy, whether that policy is good or not good. Right. For example, if we change it into not buying 10%. Or sell 10%, sell the whole thing, buy a lot of things out if it hit the threshold, and you can evaluate those policy from the simulation. Okay, you can increase the number of simulation. If you repeat it a lot of time, you get different change in, even though you can have different change. This is not stock price. Should be the amount of the amount. Sorry, this is not stock price. Let me scratch it out. Wrong. Right. This is the should be portfolio. Right. So from this one, you can evaluate different strategy. Right? When you have different strategy, what would happen? Right? Having strategy 1, your words will go down. Strategy 2 is still go down. Seems like strategy number 3 is the best. Then you can pick the strategy number 3 to do the robotic trading for you. Okay, so this is the strategy evaluation using Monte Carlo. You can perform Monte Carlo simulation with different strategy and pick the best one out. Right, you can do. You can also increase from like 25 days to a year and see what happened. So this allows you to see the projection of the long run on what would happen if you using this strategy and then evaluate it throughout the years. Okay. Right. So that's the third example. There's no code there. You can try it out yourself. Try implementing it. There's no code there because the other one, the next one will be more complicated. You can take that one, and if you want to implement this one, try it yourselves. What you need is to just, let's say, just like you see, starting from this value, and then in your for loop, sampling this value. Right, sampling this value out, add to the price, and then you get this price. From this price, you can calculate this out, and then make decision on that. I actually did this on Excel. I did not use R at all for this example. I just use Excel and then use the Excel to do the whole thing here. You can see that you can actually perform simulation using the Microsoft Excel like that. Okay. Try it yourself for this one. And if you wonder if you get it correct, you can ask me later on.